start by thanking the sponsors as well. I don't have a sponsor slide, but Matt showed it in between. If you meet any representatives from the sponsor in the lobby or somewhere else in the world, say thank you. There are so many good data events run thanks to nice sponsors. I'm not sure they get a heck of a lot back, to be honest. I'm not sure it's not every event is paying off commercially, but there are some really good sponsors who are really fantastic for the community. So thank you to them. And welcome to my session, which is, are you drunk, SQL Server? Where did that estimate come from? And I think if you ever looked at an execution plan, you probably did it because you had funky performance in a query. And you probably asked the same question. Maybe not, are you drunk, SQL Server, but definitely, where did that estimate come from? So we're going to look at a few cases. We could talk for days and days about cardinality estimation. So I'm just going to show a few kind of typical cases where I often find that the estimation isn't perfect, to say the least. And I failed to change pictures. There we go. I put up a poll on Twitter yesterday. The question was, now an important question, do I now create a PowerPoint presentation? And the result of the poll was, yes, I should create a PowerPoint presentation and it should have cat pictures. But to be honest, I added another demo as well. So chances are I will have, I added the PowerPoint and I added some demos, so I will probably run over a little bit. I always do, to be honest. It doesn't matter how well I plan, or if I plan, I do run over anyway. So who am I? I am Magnus. I am a SQL Server person. I do both DBA consulting and development consulting. I have worked with SQL Server since, I don't even think we had Enterprise Manager when I started with SQL Server. So it was SQL Server 6.0 is the oldest version I worked with, but I touched it only to migrate it to a SQL Server 7 instance. But that's when I started, and the last, say, maybe 10 years, SQL Server is the only thing I've worked with, and the things around it, of course, some PowerShell, etc. But SQL Server is what I do. I used to be able to write some .NET code. I don't know how to do that anymore, to be honest. I think the most, or the only important part of this slide is my Twitter handle, which is Transmocopter, and that's also the name of my company. So find me on Twitter. The demos will be, or they are already on GitHub, so github.com/Transmocopter, and you will find a repo called presentations, where you'll find this one and others. So the session content is some cat pictures, and then the rest will be demos. So, and we're actually done with the cat pictures. So the rest of the session will be demos, I think. Let's see. Yeah, no more cat pictures. So I'm going to switch over to Management Studio, and that will be our presentation tool for the rest of the session. If you just made it in here, Matt just said just before I started that if you have questions, please type them into the Q&A panel. There is a chat and there is a Q&A panel. The chat can become chatty. So if you type it into the Q&A panel, you're more sure that Matt will see the question and he will relay it to me. So I'm going to head up to the top of this script and take away this ugly execution plan. And first, I'm going to show a little bit about the database I have created. It's mainly one table that we're going to be interested in. So the database is called stats_demo. It has a table called sales.orderHeader with some columns. So if I zoom into them, that should be good. We have an order header ID, which is an identity column. We have an order date, which in an order table is quite a normal column for your predicates when you query the table. We have a couple of foreign key columns to the customer table and the customer address table. We have a bit flag to tell us if the order has been shipped or not. And we have a discount and an invoice amount. And please don't try to build a order system based on this table, but it kind of works for demo purposes. Because it has some columns with a high density, some with a low density, etc., etc. So it's fun to query this table. To create it, there is a setup script in the repo. So if you want to create this database and run through the demo yourself, the only thing you need is AdventureWorks 2014 installed on your instance, and then you can run this setup script. Because basically the whole database is just an explosion of AdventureWorks 2014 data. Let's remove the Object Explorer. What I've done is I prepared this table, the order header table, with roughly 12,500 rows per day for 100 days. So from August 25th back 100 days. It's an even distribution of number of rows per day. And I have updated the statistics just when I added August 24. And then I added the orders for August 25. So we will have 100 steps in a statistics histogram, which represent perfect statistics because they were updated with full scan. And then we have 1 day which falls just outside of the statistics histogram, which is also a kind of normal use case. You will always have some rows added to a table after you update your statistics. We can have a look at the histogram for the order date. So we will see that the national day for Norway, 17. May 17 is the first day. And then if we scroll to the end, we see that August 24 is the last day. So that's what we have in this table. These 3, 4 are just for reference. We will use SysDMDB stats properties throughout this session. But if you want something that you're sure it's going to work in older versions of SQL Server, then you're going to have to use DBCC show statistics. I think these came in something like SQL Server 2014 or maybe even 16. So, but they work nowadays if you have a new version of SQL Server. So for the first part of the demo, we're going to run some queries which are super simple. They're going to be against one table only, no joins. We're only going to have one predicate. And for the most part, we're just going to do an aggregation, a count star. So we should get, it should be fairly simple for SQL Server to come up with a good execution plan for it. But what we will focus on in this first part is just the estimation of how many rows does SQL Server estimate to come out from each query. So what I will start doing is to set the database in compatibility level 110, which represents SQL Server 2012. That is the last version that we had before we got the new cardinality estimator. And then I'm going to change to compatibility level 150, which is SQL Server 2019, to see what the new cardinality estimator can do for us. So I'm going to start with just a count star from sales.orderHeader, where the order date is August 24. I'm using an option recompile so I don't get trapped by some forced parameterization for these constants, because then I will always get the same execution plan, and that wouldn't be any fun. So let's execute. The numbers we get, well, we can just see that we have 12,496 rows for this date. And if we look at the execution plan, we see that SQL Server estimates 12,496. Well, that's the actual, and the estimation is this one, 12,621. And it's off. It's not off by a lot. But if you would see this the first time, you would probably be surprised that it's off. Because if we go back to the histogram, DBCC show statistics, go down to very bottom, we have equality rows 12,496 for the date that is in our predicate. So that's one interesting thing. Let's see if it changes. If we change version of SQL Server to 2019, we're running the same query. And we are getting the same estimation. So 12,621. And as I said, it doesn't matter at all if it's off by a few rows, but I think it's interesting to try to find out where are these extra rows coming from in the estimation. They're certainly not in the histogram, and they're not in the table, to be honest. We could try some funky hints to use the cardinality estimation in SQL Server 2019. It won't make a difference. We're going to get the same estimate. So where does it come from? Well, it comes from the fact that we actually added rows to the table after we updated the statistics. And if we look at sys.dmdb stats properties for the ix_order date index in this table, we can see that we have a modification counter of 12,498. And we have 100 steps, which the steps are not that interesting in itself, but the interesting part is that we have 100 distinct values in the histogram. Or in the table. So what SQL Server is going to do is to look at, where are we? Here we are. So SQL Server is going to look at the modification counter divided by the number of steps, and then add that to whatever value it finds in the statistics histogram. So the more modified rows we have, the higher estimation we're going to get. A modification counter means we changed something. So if we delete 12,500 rows instead of adding them, we're still going to get this estimation. So, which doesn't make a lot of sense, but that's how the estimation will work. So if we just look at this formula, we will see, okay, 12,620.98. So that's 12,621. So there's no magic in that estimation. It's wrong, but it's not wrong in a way that's going to affect our query. So what we can now do, which will probably be a bit more interesting, is to look at values which are not in the histogram. So we're going to go back to SQL Server 2012 and query for the order date August 25, which is not in the statistics. And we run the query, we see that we get a result. And if we look at the execution plan in SQL Server 2012, we had the estimation of 1 row. In this case, all we're doing is a stream aggregate. We're just counting rows. So there are no other ways to solve this issue. Well, we could, of course, scan the clustered index, but that would be super stupid. So we will get an index seek and a stream aggregate. There is no memory grants that could be too small or anything. So this poor estimation doesn't matter for this query. But if we do change the query just a little bit, include another column, for example, instead of just doing a count star, then we will run into problems with a bad execution plan based on this bad estimation. So let's look at such a case. I'm going to include the IO statistics in the query. And I'm going to start with the query for August 25 to see how does SQL Server solve this thing. And what I'm doing is I'm selecting the customer ID, which is in the index ix underscore order date as a second key column. But I'm also including is order shipped, which is in another index. So somehow SQL Server is going to have to find both the customer ID, which is included in the index for the predicate, but also get the is order shipped. So let's start with August 25. And we will start with the execution plan and see a plan where it kind of makes sense. This is the intuitive way to do it. You do an index seek to find the rows in the ix order date index. And then for each of them, you try to find the is order shipped, either by a key lookup, or you could probably find it in the index for ix underscore is order shipped, which is also in the table. But in this case, SQL Server decided to do a key lookup against the clustered index. And really, if the estimation would have been perfect, the estimation is one row, then the estimation also means that we do this key lookup once. And then it doesn't matter if we do a key lookup to the clustered index, or if we do an index seek and the nested loop from another index. It's just going to run once. But in reality, we get 12,500 rows. So this key lookup is executed 12,500 times. That's not so very good. And if we look at the messages pane, we see that we get 37,532 logical reads. That's a lot of IO. If I now run the same query, we're going to get the same number of rows returned, but for another date. We will get this plan, which intuitively looks like a bad plan because it's a clustered index scan. And in fact, it is SQL Server scanning the whole clustered index, every damn row, every page. You probably don't want that for a big table, but if you can choose between this plan, which scans the whole table, and the plan that does 12,500 key lookups, I'm going to go for this plan. Because if we look at the IO for it, it's only doing, in quotes, around 6,000 logical reads compared to, was it 35,000? So we went from a bad estimation where it doesn't matter what the estimation means to a bad estimation where it makes a lot of difference. So let's switch to SQL Server 2019. I remember when SQL Server 2016 was released, Microsoft said, SQL Server 2016, it just runs faster. And well, sometimes it does, not always. But what came with SQL Server, actually already in SQL Server 2014, was the new cardinality estimator. And one of the things it tries to address is this situation where you have a predicate for a value which falls outside of your statistics histogram. I'm just going to make this window a little bigger so we hide the cat picture from it. Okay, so let's run this. Did I change? There we go. SQL Server 2019. We are going to run the count star query to begin with. We get, of course, the same number of rows. The actual result hasn't changed. We get an execution plan with an index seek, and that's the only way to solve it, like I said before. But we get a really funny estimation. We get an estimation of 1,124 rows. So what? That's not 1. So it's better than 1 when the real value is 12,500. But it's not really close to 12,500. So it's kind of off by, orders of magnitude, which will turn out to actually make a difference when it comes to query execution as well. But let's see. We could use a hint to go back to the old behavior to see if that's the reason. Is it in fact the new cardinality estimator that caused this? So I'm going to force the use of the legacy cardinality estimation. And indeed, I go back to getting an estimated number of rows per execution, 1, an estimated number of executions is 1. So 1 row. Okay, so it's the new cardinality estimation. But what does this mean? 1,100 and in fact, if we run the query again, what you see in the graphical part of the execution plan, you will see an integer. But if I now hover over the operator, we see that this is in fact the estimated number of rows, 1,123.51 rows. So that leads us to think it's not coming from the histogram, because the histogram doesn't have fractions of rows, it has whole rows. Okay. So after some thinking and reading, I found out that the formula which SQL Server is going to use is either this one, the square root of the number of rows plus the modification counter from the statistics object. It will then compare it to whatever it gets from using the density vector for the statistics or the index. So this number, we're going to wait with the square root calculation bit, actually. So let's start looking at the density vector. And density for the order date column in this index is 0.01. So every 1 in 100 row would be a specific or a specific date. So if we just calculate 0.01 multiplied with the rows plus the modification counter, we will get 12,622.85, which brings us pretty close to the real estimation. But, and this is one of the times I'm thinking, are you drunk? Someone, I can't see that they were thinking straight, at least when they came up with, well, let's see if the square root of the total number of rows in the table is a smaller value than whatever we get from using the density vector. And in that case, let's use that estimation. So that's going to be, 1,123.51 and then some more decimals. But this is the estimation that SQL Server is going to use. So it's an order of magnitude too small. Does this make a difference? Well, let's see what happens when we query for the customer ID and the is order shipped in SQL Server 2019. We can start with the predicate where we have the value in the statistics histogram. And we will see that we get a pretty good estimation, 12,621. And SQL Server is doing a clustered index scan. And this is what we saw in SQL Server 2012, that this performs better than doing 12,500 keylookups. So let's see if it's true that SQL Server 2016, 17, and 19 just runs faster by running the query with the predicate for a value which is outside of the histogram. And no, because of this estimation, 1124, SQL Server thinks for a while and figures that I'm going to make a key lookup 1124 times because that's going to be faster than scanning the clustered index for the order header table, which is true. It would mean only 3,400 IOs instead of 5,000 IOs, which we get when we scan the whole table. But since the real number of executions is 12,498, we get 38,000 IOs instead. So no, SQL Server 2016 doesn't just run faster in this case. And what's kind of interesting is if I would have added another 100 days to the table, the number I would get from the square root of the total number of rows in the table would have been so big that SQL Server would have chosen to do a clustered index scan instead. So we get more unpredictability from this type of cardinality estimation. This, by the way, if you haven't heard it, this is called the ascending key problem. When you have an ever increasing key, meaning that you run your night batches, update your statistics, and the first thing in the morning, you're going to add rows which have a value which is higher than the previously highest value for a column. And the way that we used to address it back in the days was to enable a trace flag to get the column marked as ascending, and that way SQL Server would revert to using the density vector, which would have given us 12,623 as the estimation, which is pretty close to the truth. But instead, SQL Server, Microsoft decided to also introduce the square root of the total row count and use that if it's smaller than the density vector calculation, which to me makes very little sense, to be honest. Okay, that's demo number one. It's pretty simple use cases. Do we have questions, Matt? Or is it all empty in the Q&A?
It is empty for now. I think
right.
Your knowledge has stunned them into silence.
All right. I'm going to go ahead with a little bit more complexity to the queries. And I realize I have to talk a bit faster. That's going to be fun. So I'm going back to SQL Server 2012. I'm going to introduce another predicate to my queries. So I still query for order date, August 24. And I'm going to add customer ID 3933. It's just a randomly selected customer ID, which has orders. So did I run the alter database statement? Now I did at least. And let's run the query and see what we get. We get one row. We get an execution plan with an estimation of 2 rows. Or if we zoom into it, we see that the estimation is in fact 2.49271. And this actually got me walking in the wrong direction for a while, because I didn't remember that I actually added the customer ID to the same index as the order date. So what SQL Server will do, it can't use the histogram to come up with a combination of order date predicate and customer ID predicate, because the histogram will only include statistics for the leading column in the index, which is the order date. The only way to use the same statistics or the same index statistics to also estimate anything based on the customer ID is to use the density vector. So I started looking at the individual estimations. Let's look at customer ID 3933, where the estimation is 213.929. The order date 12,621. Tried to come up with some kind of combinations between them. But in the end, what we have to do is to look at the density vector and look at the density for the combination of the order date and the customer ID, which is this, a small number, 1.9945 multiplied with 10 to the power of 6, I guess this mean, or 10 to the power of -6, sorry. So a small value. So if we take that number, let's see that I have the right number. Yeah, I do. And multiply it with the number of rows from the statistics object, we get this estimation. This is one of the things where SQL Server is not consistent, at least not in SQL Server 2012, because this time we're taking the density and we're multiplying it with the number of rows, not with the number of rows plus modification counter. So it doesn't make a big difference. 2.49 something something, the real value is 1. And to be honest, this is kind of a hard math to figure out what would be the best way to estimate when we have a combination of order date and customer ID, as in this case. Even if we know exactly how many orders we have for a specific date and exactly how many orders we have for a specific customer, the combination of them isn't that easy to figure out. I have another demo which I won't show today, where I have some cars. So I have Volvos and Saabs, Swedish car models or car brands, and 3 models. And then I query for a combination of Volvo and the model 93, which Volvo never made. But I mean, I know that that would be 0 rows, but SQL Server doesn't know anything about cars or orders for that matter. It can just look at the numbers it has in the statistics. So I think SQL Server is doing a kind of decent job here. Let's go to SQL Server 2019 and see what we get for the same. We get a slightly different estimation, 2.51764. And the reason is that from SQL Server 2014 and later, the modification counter for the index or for the statistics is also taken into the calculation. So the same density, but we multiply it with the rows plus modification counter and come up with this 2.51, etc., etc. Does it make a difference in this case? No, not at all. But as we saw for the previous queries, there is a certain tipping point to where SQL Server decides to solve a problem using another method, which could be better or could be worse. So even if it's just small differences, it sometimes will make a difference, which you will find out when you do an upgrade and realize that 10 out of 100 queries get really poor and or unpredictable execution plans. Let's look at, again, single table, but this time with no covering index on it. So we're going to look at the customer address ID instead, which is not covered by the order date index, and see what we get. I'm going to switch to the right compatibility level first. 2 rows, an execution plan, which makes an index seek to the customer address index, and an index seek to the order date index, and the hash match to combine them and come out with 2 rows. Decent estimation, I would say. We get 2.11442 as the estimation, and the real value is 2 rows. So that's close. Chances are for just any other value for customer address ID, it would have been poorer estimation, but with this tiny number of rows, it doesn't really matter. The execution plan is going to be good enough anyway. But again, if we come up to a certain tipping point here, where it makes sense to do a clustered index scan because it's just faster to scan the whole table, that's when you're going to start suffering from estimations which are not super perfect. The way that SQL Server 2012 comes up with this estimation is to look at the estimated number of rows for customer address ID 5442 individually, and the estimation for the order date. And so that gives us a selectivity for the combination of these 2 predicates. And we will come up with the estimation 2.1144 something, which is what we had in the execution plan. Let's look at a date which is outside of the histogram again. SQL Server will now estimate 1 row to come out of the order date index seek, and then SQL Server does a key lookup instead. So is this really a good plan? We have an estimation of 1, so SQL Server decides to do a key lookup to the primary key to find out about the customer address ID instead of using the index for customer address ID. And the reason is that, well, in SQL Server 2012, as we have shown, this predicate produces an estimation of 1 row, and then that's basically the same as 0 rows. So SQL Server is going to figure, I can use whatever method I want. I'm not going to touch that table again anyway. And then it turns out it has to do it 12,500 times. So the IO statistics for this one is 37,532 to return 1 row. Oops. But for sure, this must have been solved in SQL Server 2019. We have to find 1 query where SQL Server 2016 and later is faster. So let's skip the August 24th. Let's look at it actually. It's kind of interesting because we get an estimation here. We have to look at the hash match here to see the number of rows coming out from that one. So 2.17849. That's how many rows SQL Server thinks fulfills the combination of predicates. So if we would look at the same method, the estimation of customer address ID and order date individually, we would not get the same estimation as we have in the execution plan, which was $2.17849. And this formula, which worked in SQL Server 2012, gave us 2.13. So close, but not the same. We could try something fun and use some undocumented trace flags. I don't recommend using undocumented anything, but for troubleshooting, if you know that there is a trace flag 2363, which reveals some information about how SQL Server does cardinality estimation, we could use that. And then trace flag 3604 will output debug information to our messages pane. So let's run the query and focus on, there's tons of information in here, but I kind of happen to know that I need to go down a bit and find scroll. Here we have it. So we have a selectivity of 8 point something, which is small. We see that we have, if we go up, we see that we have a method for computation, which is using a combination of order header ID in combination with order header ID. It has nothing to do with our predicates, to be honest. But what SQL Server will do is to look at the, since in a hash match, what you will get out from both this index seek and this index seek is going to be the order header ID. So SQL Server is looking at the selectivity or the density for the order header ID and combines it. And to me, order header ID, it's the primary key. So it would have a selectivity, which is always 1 divided by the number of rows. But with some funky method based on the number of modifications we have had in the table since we started, SQL Server comes up with 2.17849. I'm not really including this to show off that I know some trace flags, but it's really interesting to watch the number of different methods for estimation that SQL Server tries before it actually decides to go for one. And very often the method which is used is the one that produces a row count estimation, because some of the methods produce a 0. But if you get a row count estimation from any of these methods, SQL Server will very often choose the lowest number, which will lead to this kind of execution plan where you do index seek, and in this case you have a hash match, but it could just as well be a nested loop join. That is the result, the resulting operator, and that's going to be really problematic. For you if SQL Server comes up with a too low estimation, as it does with, for example, the case where it uses the square root of the total row count. It's almost always going to be too low. So that's kind of a warning. This is another fun thing, and we're we're going to get a smaller output from the trace flag 2363, but I'm going to look at orders where is order shipped equals 1. And in my table, there are exactly 0 rows where the order is shipped. So let's just look at the methods for computation. SQL Server starts with this method. It looks at the is order shipped from stats ID 3. So that's the index for is order shipped. And it now says calculator failed, replanning. What that means is that this predicate is not found in the histogram. So then SQL Server thinks, okay, I failed to find it in the histogram, but my smart developers decided that I'm going to have a solution for the ascending key problem. So instead of using the histogram, I'm going to come up with a fun formula for cardinality estimation. And what formula did it come up with? It came up with 1124, which is the square root of the total row count for the table. This will be a problem when you combine it with an order date, for example, because SQL Server will come up with an estimation which is just wrong and use a bad method to solve the problem or the query. Finally, let's do some real joins instead of just single table selects, because that maybe is more realistic in your databases. You have more than one table. So I'm going to turn statistics IO on. We are starting in SQL Server 2012 mode. And a very typical ascending key problem query. We are selecting the average discount and the region for orders, for a certain order date and some grouping, etc., etc. So let's run the query and see. We get some fun discount averages. And to be honest, I have the same discount on every row. So the numbers are not interesting, but the execution plan is interesting. So what does SQL Server do? It decides that, okay, I'm going to get 12,621 rows from the order date predicate. And I need to join with customer address and locations. And since there are very few rows in customer address and in locations table, I'm going to start by scanning those two tables, combine the result with a hash match. Then I'm going to get the actual orders from the order header table and combine the results with a hash match and then do some aggregation. It makes total sense that this is the execution plan that we get because we have good statistics. The estimation is more or less accurate on the predicate that we have for the order header. Let's look at the order which is outside of our statistics. And now it's not so good anymore. SQL Server starts with an index seek to get one order, but in fact gets 12,500. Then does 12,500 index seeks on customer address and the nested loop join, and then does 12,500 key lookups, and then 12,500 cluster index seeks to the locations table. So that is 37,500 lookups or seeks instead of 1, 2 scans and 1 seek and a scan for the order date. Since the plan, before it comes into the stream aggregate operator, we need to sort the data. So we get the memory grant for one row, and we get 12,500 rows into the sort operator. So it's spilling to tempdb as well. So, okay, this was bad. Let's go to SQL Server 2019, which, as we know, has a perfect solution for the ascending key problem. We're going to start with a good predicate, which is found in the histogram. We are going to look at the execution plan, and we are going to see that we get a nice plan. Clustered index scan on customer address, clustered index or an index scan on the locations table in an index for it, an index seek in the order header table, and some hash match. Perfect. This is what we want. This is what we had for good statistics in SQL Server 2012. So nothing changed there. And now let's look at the predicate for which we don't have statistics. And yeah, we start with an index seek on order header to get 1124 rows, and then we do an index scan on customer address, and then we do an index scan on locations. Whew. Luckily enough, we actually get more or less the same plan. It's in a different order, but still SQL Server decided to do a clustered index scan on customer address and locations. So good, right? The solution we have for the ascending key problem in SQL Server 2016 works, right? Let's try something else. I'm going to begin a transaction. I'm going to delete all the orders which are from before July 15. It takes a little while. I could say something fun in the meantime. I don't have anything fun to say, so I'm going to update the statistics instead. And then I'm going to create some new orders for August 26. So basically, since I deleted so many rows, SQL Server is going to do an auto update statistics for me. So I'm beating SQL Server to the pole and update the statistics myself. But then I add some orders for the next day to get the ascending key problem back, to see how well this method now works. Now I will run the exact same query, but with the predicate August 26, our newly added rows. So we have kind of created the exact same situation, but with a few, not as many rows as we had before in the table in total. So I run the query, I look at the execution plan, and oh, now the estimation is 733. And it's still the square root of the total row count for the table. And then what's this? We get a sort operator over here. So we get a different plan. And we still get the clustered index scan, and we still get an index scan for locations, but we get a sort operator introduced, which is costing, well, the cost is 11% as the estimated cost. But as we can see here, we get 1,700% of the estimated rows into it. So the real cost is going to be slightly bigger, especially since we get the spill to tempdb. So it turns out SQL Server 2016, 17, and 19 wasn't so smart after all in trying to solve the ascending key problem. So if we now look at some statistics, IO on and rerun the query, we will see that we have, well, kind of a decent statistics. We have 38 rows on the order header table, 17 on the customer address table, and some on the locations table. And we have some reads on a work table. So that means tempdb. So if we now look at the execution plan, we see that, okay, the sort operator is still spilling to tempdb. Chances are if we rerun this query a number of times, let's do it. We still have the sort operator spilling to tempdb. Okay, I thought, to be honest, that SQL Server 2019 comes up with not actually better estimations all the time, but a way to handle situations where the estimation is poor. So in this case, we really have poor estimations, but very often SQL Server 2019 will, after a number of executions, it will adjust the memory grant for operators that is spilling to tempdb. And the next time I run the query, it's going to give the query a bigger memory grant for this sort operator. Not in this case, though. That's all I had. I still have 4 minutes to go, but I think I'm going to stop there anyway. Not try to dig out some other demos. I hope you found it, even though it's a lot of numbers, it's a lot of execution plans, which looks a bit similar. I have at least shown you a number of cases where the new methods for cardinality estimation in SQL Server 2016 and 17, 19, SQL Server 2014 even, which was supposed to give us a better execution plan in the end, better estimations to give us better execution plans. It sometimes actually makes life worse, and it doesn't always make life better, or in too many cases, I think we get the same poor estimations. And to make life a bit worse, back in SQL Server 2008 and 2012, we could introduce some trace flags to mark some columns as ascending in our statistics and kind of force SQL Server to always use the density vector to do estimations for those columns. If we try to do the same in SQL Server 2014 and later, those trace flags have no effect anymore. So even if we revert to legacy cardinality estimation, which is now also database option, database scoped configuration, those trace flags have no effect at all. So we're kind of stuck with the square root of the total row count, which is quite too often the way to do estimations. So I'm not particularly happy with that. I'm happy with a lot of things that have come in, well, some new T-SQL language constructs and so on, but I'm not really happy with how cardinality estimation has changed over the versions of SQL Server. I'm going to go back to my cat picture. It could now say, do you have any questions? But it says no more cats. Do we have any questions, Matt?
We do not right now. That cat does look very disappointed.
Yeah,
but cats
it
often
does.
do.
That is true. It's begging for more cat pictures, but I don't have any.
Yeah, we have a kind of a cheap fountain for our cats here, and it broke. And one of the cats is quite sure that if she just continues to meow at it, it will start working again. What she doesn't know is that Amazon's bringing a new one tomorrow, but she will think she has fixed it. Yeah. So we do have a question here just now. It says, I didn't get when and why the estimation in legacy cardinality estimator for the date out of the histogram is 1 and when it uses the density vector.
Okay, so let's go back to, I think it's in the very beginning, actually. Yeah. If we switch to SQL Server 2019, I have to roll back a transaction. And now my statistics are bad. So, okay, give me a few seconds to update my statistics and then add the orders for August 26. Now my computer is making a lot of noise. I don't know if you hear that, but it does. So, and then let's go back up here. We switch to SQL Server. Here we have it. So let's make sure we have SQL Server 2019. We are going to query for, let's say, August 26, which is not in the statistics. And then we use the use hint force legacy cardinality estimation. And the reason I included it was actually to just show that we have that hint when we run into a situation where we have a query which gets a bad estimation, and we want to see if using the legacy cardinality estimator is better without changing the database option. We can do it on query level. So let's run this, and we will get the estimation 1, because this is what SQL Server 2012 and the previous versions estimated. When it didn't find a value in the histogram, it estimated 1 row. Whereas if we skip the hint and just use option recompile for the same query, SQL Server is now going to use the square root of the total row count instead. So that's the difference from using the legacy cardinality estimation. If we switch the database to compatibility level 2012, we will always have the legacy cardinality estimation because that's the only one that existed in that compatibility level. I don't know if that answered the questions. Otherwise,
yeah. So yeah, I would say if it didn't, just go ahead and mention in chat what wasn't clear. Chat seems to respond a little faster. That Q&A panel, so a little bit slow. Okay. There's nothing out there right now. Yeah, so I know we've got Kathy coming up. So it's 4:02 p.m. my time. Realize it's a bit later for you. I know we've got.
It's a good time actually. It's 10 p.m. so kids are in bed. I went to the office and I can sit here and watch Kathy. So it's perfect.
Yeah, it is funny, kind of how things have changed. I don't mind presentations that are late at night because, yeah, it's easier. Kids are asleep, pets are asleep usually, and it's a lot quieter. You know, the mailman isn't going to show up and have all the pets make a bunch of noise. So it's always good.
I have only one problem in my office. The intruder alarm is activated at 10 p.m. So that's now. So if I open the door from my office room, the alarm is going to go off and I have to run downstairs and deactivate it. And there is no way to deactivate it, before. We just say that please don't activate at 10 today. It just goes on. So I'm not going to open the door now because you will go deaf, unfortunately.
Got it. Yes, there's some nice feedback in chat. Just great session, really interesting stuff like that. It's always good to have deep dives into things like this because it's you don't see a lot of this, and it's really important.
I've been thinking about writing a blog series about cardinality estimation. The only thing I can promise is that it will not happen anytime soon because I'm so bad at blogging. I can write for days and days and then I just throw everything away and think no one is going to want to read this anyway. We will see what happens.
I'm very much the same. Yeah, I mean, I'm technically in the middle of a series, but I haven't published a new post in over 2 months. But the best advice I ever got for blogging was that, write something that helps you, and you can guarantee it has helped one person, and the rest is just, nice after that. And that's true. I mean, some of the posts I've put out really just for my reference, like I figured out how to do something and said, well, I want to put this out here. So if I switch jobs or laptops or whatever, I don't lose this.
Yeah,
Those are the
true.
most popular posts because it's just somebody else's. And I see that post still, it's years old now. Every day there's a handful of people that search for that. So yeah, it's really easy to get writer's block and leave stuff out, but don't just get it out there. But yeah, I'm the same way. I edit and edit and edit and sit on stuff, and it's not good.
I have two posts which are, I mean, they're years old now, and they're both from when Service Pack 1 came out for SQL Server 2016. One of them is the hint option use force legacy cardinality estimation, which gets, I don't know, 100 views per week. And one which is for DBCC clone database. If you have created tables in your model database, you're going to get a conflict with some sys columns ID. And that's I just wrote about it. There is no solution for it. It's still an error, I think, but it's not your own instance that is wrong, basically. And that also gets maybe 100 views per week. But they're years old, and no one comes to my blog to see if I wrote anything new. They're all from Google, of course. So,
Right.
so it seems that it does help some people.
Yeah, no, I mean, like I said, and I was on, I had a thing featured on, which I talked to you about on SQL Friday last year. I had a thing featured on a pretty popular soccer/football podcast here in the States. And those posts used to have the most views because they have a big audience and they link to my stuff about how I built the thing. But that has been surpassed by, I think, like the second post I ever made, because it's the thing people search for every single day.
Yeah.
Yeah.
Yeah, but I'm looking into, there is a Facebook group for SQL Server questions. It has thousands and thousands of users and just, I mean, hundreds of posts every day. And people come back to the same questions that, and it doesn't have to be complicated at all. It could be just, how do I write an inner join?
Yeah.
And so I think if you just want to get traffic to a blog, I mean, write about things you were struggling with 20 years ago. People are still struggling with the same issues. So.
Yeah. Yeah. No, that's true. And it really does help. And I mean, me included, I think a lot of people, they don't want to put stuff like that out there because you don't want to let on that you ever struggled, right? And you didn't know stuff.
I
But
always
yeah,
knew everything. Yeah.